Ever felt like you're just drowning in information, especially with new tech? You need the key insights, but finding a clear path through it all can be tough. Well, you're definitely not alone there. Welcome to the Deep Dive, where we try to give you that shortcut, make you genuinely well-informed without, lecture hall vibe. Today, we're diving into something pretty cool that's changing how we see and map the world around us. Terrestrial scanning. And maybe, surprisingly, it's becoming much more, accessible. Our mission today, it's really to unpack how this more affordable approach to terrestrial scanning is making 3D mapping way easier, especially for folks in government, utilities, construction, places where this data is critical. We want to look at a new way of doing things that tackles the old headaches of 3D mapping and hopefully give you some aha moments about why getting that data right is just so crucial for, everything from engineering to planning.
Exactly. And for this deep dive, we're drawing heavily from a really insightful webinar called Affordable Terrestrial Scanning. It featured some key industry players. We'll be focusing quite a bit on a presentation by Nik Smilovsky from BadElf, and also some really good points that came up in the Q&A afterwards. It feels like a real turning point for this kind of spatial data work.
Okay, let's get into it then. For years, it felt like 3D mapping, things like laser scanning, photogrammetry, it just seemed completely out of reach for so many. Our sources, Nik included, even bluntly said traditional 3D mapping kind of sucked. So what were those major pain points?
Oh, they were very real. I mean, the first massive barrier historically was just the insane equipment costs. You were looking at spending easily well over $100,000, sometimes closer to $200,000 for just one scanner.
Wow.
Yeah, that kind of money. It just immediately put it out of reach for almost everyone except maybe the really big engineering firms or, government agencies with huge budgets. Most departments couldn't even consider it.
And it wasn't just the price tag, right? Even if you could afford the gear, the learning curve was, steep doesn't even cover it.
Absolutely. It often took teams weeks, sometimes months, and maybe even longer, to really get proficient, to integrate this complicated tech into how they actually worked day to day.
Right. And the field work itself, slow, wasn't it?
Painfully slow sometimes. You had these elaborate setups and this method of kind of hopscotching across the site. You'd scan, pick up, move a bit, set up again, scan again.
Yeah.
Imagine doing that across like a whole university campus or miles of pipeline, just incredibly time-consuming.
So, okay, cost, complexity, time. What about the actual data you got out of it?
That's another huge piece of the puzzle. Because you're capturing thousands of points or pictures every second, you ended up with these absolutely enormous data sets, gigabytes upon gigabytes.
Like the big data problem.
Exactly. And that created its own set of headaches. Just processing it was confusing, time-consuming. And then trying to get that data into your existing CAD or GIS systems, that was often a real struggle. Nik Smilovsky mentioned this specifically, just getting the dots and lines on your map to be in the right place. It sounds simple, but it was often incredibly difficult, leading to frustration and critically inaccurate results. Bad digital twins.
Yeah. Defeats the whole purpose.
Yeah.
And then you had the practical stuff, like you mentioned, Nik talking about working in 115-degree heat and humidity.
Yeah.
Nobody wants to be wrestling complex, expensive gear in bad weather.
No way. Freezing cold, pouring rain. It's not ideal for sensitive electronics or, frankly, for the people operating them.
So you put all that together, the cost, the training, the slow process, the massive data, the environmental challenges. It's pretty clear why. Historically, a lot of people just said, nope, not for us.
Yeah.
It wasn't practical.
It really wasn't. The barriers were just too high for widespread adoption.
But the conversation now, based on sources like that webinar, suggests the time is right, that a new solution, maybe this solution, is here. And it seems to center around this combination of Pix4D and Bad Elf.
It's interesting, yeah. Bad Elf, they've been in the GPS game for about 15 years. Started out more in aviation and marine, places where reliable positioning is, obviously critical, but they've steadily expanded into GIS, survey, public works, and now really making a mark in 3D scanning. Their whole thing seems to be reliable, rugged GPS that works easily with the devices people already have. Phones, tablets, whether it's iOS, Android, Windows.
Right, and that leads to this BYOD idea, bring your own device. That sounds like a game changer.
It really is. The concept is you use your existing smartphone or tablet, your iPhone, for instance, which already has cellular connectivity for corrections. Then you pair it with a BadElf GPS receiver, like their main one, the BadElf Flex. And you connect that system to an RTK network, real-time kinematic, for those super high-accuracy corrections.
So you're leveraging the power of the phone you already carry.
Exactly. And Nik Smilovsky, he called putting these pieces together engineering magic, which, sounds about right. The BadElf Flex itself, he described it as a Swiss Army knife of GPS.
Okay.
It's capable of survey-grade accuracy. We're talking centimeter-level precision. It have a good antenna, a screen, buttons, like 12 hours of battery life, which is pretty solid. And it can act as both a base station, maybe on a known point, or as a rover collecting the data. Plus, it connects to other gear. There's also a smaller, maybe more affordable version, the Flex Mini, for different needs.
So the whole point of this system, this combination, is getting that high accuracy, synchronous data, making sure everything lines up perfectly for what Nik called a happy digital twin.
That's the goal. A trustworthy, reliable digital model where all the pieces fit together correctly in space and time. Moving beyond just collecting points to creating an integrated, accurate representation.
Okay, that makes sense. And this ties into something fundamental. They talked about the point of beginning, or POV.
Yes, absolutely fundamental. Nik really emphasized this. If you think about any good geospatial project, it needs a strong geodetic foundation. It's like the underlying grid system. He used the analogy, it's the rug that ties the room together.
I like that. Like in ancient Rome, right? Everything measured from a central point. Or any construction site today starts with a known survey monument. You need that starting point, that geospatialness, as Nik put it.
Precisely, because the old saying holds true. Crud in is crud out. If your initial positioning, your geospatial reference, is inaccurate, then nothing else you build on top of that will be accurate either.
Your beautiful 3D scan is just floating randomly.
Exactly. You'll never get a good digital twin. It's the absolute bedrock.
So this raises questions about coordinate systems and datums, things like state plane versus UTM, feet versus meters, different height measurements.
Crucial considerations. Are you using a global system like Universal Transverse Mercator, or a local one like a state plane grid? U.S. survey feet or international feet or meters? Orthometric height sort of means sea level or ellipsoidal height from a geometric model. These are just different, very precise ways of defining where your data exists on Earth. If you don't get this right, your data won't line up with existing maps or engineering designs or anything else. It makes the data essentially useless for integration.
Okay, and that's where ground control points, GCPs, come into play, those physical points on the ground.
That's right. Whether it's a dedicated target like the Pix4D ones, or maybe just setting up the BadElf Flex itself on a known survey marker, these points physically control the data. They anchor your scan to the real world, to that known coordinate system.
And the BadElf Flex, especially with that RTK connection providing centimeter accuracy, that's what gives you that reliable anchor point.
Exactly. It provides that high accuracy, synchronous starting point and ongoing correction that ensures everything lines up for that happy digital twin. It ties the virtual model securely to reality.
Got it. Okay, to make this less abstract, they talked about a real-world example, right? An ADA compliance project, American Disabilities Act.
Yeah, a really good case study from UTSA, the University of Texas at San Antonio. They needed to survey things like ADA ramps, crosswalks, curb cuts, other outdoor assets. And the key challenge there is capturing the slopes, the running slope along the path of travel, and the cross slope side to side. You need to do that accurately, precisely, and repeatably for ADA compliance.
And how did they use the BadElf and Pix4D system for that?
It sounded remarkably straightforward. You pair the BadElf Flex to your phone or tablet using Bluetooth. Open the Pix4D Catch app, that's the scanning software, and then you engage the RTK corrections. And they showed the accuracy difference. Without RTK, maybe you're getting around 8 inches of accuracy, which is okay for some things. But turn on RTK, it drops down to like 0.8 inches, sub-inch. That's survey grade, right there from your phone, essentially.
Oh, that's a huge jump just by walking around.
Pretty much. Just walking the path, scanning the ramp or crosswalk. Then back in the office, they uploaded the scan data to Pix4D Cloud for processing. And from that point cloud, they could easily extract the measurements they needed, cross slopes, running slopes, generate elevation profiles, label the slopes as percentages, and then crucially, export that information. They could take that complex 3D point cloud and turn it into, say, line work for the slopes as a DXF file for CAD, or maybe polygon features for ramps as a shape file for GIS, actionable data.
And they showed how that data then fits right into something like ArcGIS Pro.
Seamlessly. They could bring it in, visualize the slopes, maybe color code them based on compliance, running slope under 8%, cross slope under 1.5%, verify everything met the ADA standards.
And then easily share that verified map or data through something like ArcGIS Online, so decision makers or other departments could see it.
Exactly. It makes the whole compliance reporting process much more visual, much more efficient, and much more auditable.
So compared to the old way, I guess that involved spreadsheets, maybe marking up aerial photos, manual measurements with levels.
Yeah, often very time-consuming, prone to errors, and crucially not inherently tied to a precise geospatial location. You might know the slope, but maybe not exactly where that ramp is in the state plane coordinate system.
Right.
This new method gives you georeferenced 3D data. It's accurate, it's tied to a proper coordinate system, and it requires very little post-processing to get it ready for use. Faster, more reliable, better documentation.
That makes a lot of sense.
Yeah.
Okay, this deep dive wouldn't really be complete if we didn't touch on some of the practical questions people probably have, especially things that came up in that Q&A with Nik Smilovsky. First big one, cost. You mentioned the old scanners were astronomical. What about this setup?
Right, Nik addressed that directly. He said that while, exact pricing varies, the full setup, meaning the BadElf Flex hardware and the Pix4D software, generally falls into the sub-$10,000 range.
Sub 10,000 compared to 150K, 200K?
Exactly. It's a massive difference. It fundamentally changes who can access this level of technology. Smaller towns, private surveyors, construction companies. It suddenly becomes feasible to bring this capability in-house. It really democratizes high-accuracy 3D mapping.
Okay. And what about those RTK correction services? Are you locked into one specific provider?
Good question. Nik confirmed the BadElf Flex is pretty versatile. It can use basically any public RTK network, and a lot of states offer those now, sometimes for free.
Yeah.
It also works with most commercial paid RTK networks. So
Right.
you have options, you're not tied to one specific, maybe expensive proprietary service. That adds flexibility.
That's good. Now, data formats. Old scanners often output things like E57 files, right?
Wow.
What comes out of this Pix4D system?
So it can output standard point cloud formats like LAS and LAZ, which are widely used, and mesh formats like SLPK if you need a 3D model. But Nik made a really important point. Often what people really need isn't the raw massive point cloud. They need the useful information derived from it.
Like the lines and points you mentioned for the ADA ramp.
Exactly. The Pix4D software lets you vectorize the data, turn the scan into lines, areas, points, and those can be exported as standard DXF for CAD, shapefiles for GIS, or even simple CSV tables.
So much lighter, more usable files.
Much lighter and directly usable in the software engineers and planners are already using. It cuts out a lot of intermediate processing steps. You get actionable data more quickly.
Okay, practical scenario. What if you lose that GPS signal? You walk under a bridge or you're downtown between tall buildings. Does the whole thing just stop working or lose accuracy?
That's a critical point for real-world use. The system actually uses more than just GPS. It uses the phone's capabilities, specifically visual inertial odometry and ARKit technology.
Okay, what does that mean?
It means the phone is using its internal motion sensors, the IMU, and what its camera sees features in the environment to track its own position and movement. So even if the GPS signal drops out briefly, the system can keep tracking based on visuals and motion.
Oh, okay.
Now, over long distances without GPS, or in areas with very few visual features, like a long, blank tunnel wall, this visual tracking can drift a bit. But the key is, as soon as the RTK GPS signal comes back, it corrects any drift. And Nik also emphasized you can still use traditional ground control points, even just simple spray paint marks on the ground that you locate accurately with the Flex. These tie the scan down, especially in tricky GNSS environments. You can even see your path, the trajectory in the output, to visually check for any weird jumps or drifts.
Got it. So there are safeguards. Okay, thinking about the listener now, you might be hearing all this and thinking, okay, cheaper, maybe easier, but still sounds kind of techie, maybe still out of reach for my team. What's the counter to that?
Well, the big thing is that bring your own device concept. As Nik pointed out, if you or your team already have reasonably modern smartphones or tablets, especially iPhones, which have good AirKit support, you're honestly halfway there.
Right.
You can literally go download the Pix4D Catch app right now. It's free to download, get a trial license, and just start scanning something simple, your office, the curb outside, just to see how it feels, how it works. The barrier to entry to just try it is incredibly low.
And you mentioned integration. A lot of organizations already use GIS apps on tablets, right?
Absolutely, think about it. Many field crews already use Esri's ArcGIS field maps, or Survey 123, or Quick Capture on tablets or phones, maybe with a basic GPS. This BadElf system integrates right into that. You're likely already collecting some kind of GPS data. This just upgrades the accuracy and adds the 3D scanning component using tools that feel familiar. BadElf even offers trial units of the Flex and training to get people comfortable, help them get from 0 to hero pretty quickly.
So you could be out mapping, say, culverts. You use field maps to capture the basic location, the pipe size, material condition, the usual stuff.
Right, collecting those XYZ points and attributes.
And then right there, you fire up Pix4D Catch with the BadElf Flex connected, do a quick walk-around scan of the culvert headwall or any visible erosion.
Exactly. And then, maybe with a little bit of that engineering magic back in the office or even automated processing in the cloud,
You suddenly have not just the points, but a full, accurate 3D model of that culvert and its surroundings, all tied together in one digital twin.
precisely. It adds a whole new dimension, literally, to your existing data collection. And Nick's point was that it's far more accessible and achievable now than people might realize.
Okay, so wrapping this up. Today, we've really dug into how this more affordable approach to terrestrial scanning, using tools like BadElf and Pix4D, is making a real impact. We've seen how it tackles those old, frankly huge barriers of cost and complexity, how it delivers impressive survey-grade accuracy. And we looked at real applications, like that ADA compliance work showing its practical value, all using mobile tech that many already have.
And that leads to a final thought, maybe something for you to mull over. Consider the field data you're collecting right now. With these kinds of accessible, affordable 3D mapping tools genuinely within reach, what insights might you be missing? What's the untapped value in not capturing the full spatial reality of your assets, your projects? How could shifting your methods slightly, moving towards creating these richer, accurate digital twins, potentially unlock new efficiencies, better decisions, maybe even improve safety in your own operations?
It's a powerful question. We definitely encourage you to explore this technology further. The tools are more accessible, the learning curve is flatter than it's ever been, and the potential benefits in accuracy and efficiency are just immense. Keep asking those big questions. Keep exploring what's possible with geospatial data.